In this first video, we're going to go ahead and talk about coterminal angles. So this might be a little bit of a review for you, but if you're not comfortable with angles, let's go ahead and jump right in. So recall that a complete rotation of a ray results in an angle measuring 360 degrees. So let's see what this looks like. So if we have our ray starting over here and we rotate it, which is how we measure, all the way around, that's going to give us a total of 360. Or you can see it looks like a circle, right? So that's going to be a complete rotation. So why is this important? Well, when we're talking about coterminal angles, we're talking about angles which end at the same place as another angle. Well, how is this possible? Well, the idea is if we rotate around and end up at the same angle, placement of the angle, it's considered to be coterminal. So what you do is you take your angle and you just add or subtract 360 degrees and you'll end up at the same place. This is kind of like when someone says, oh, I'm going to rotate 360 degrees. You're basically going to end up at the same place you started with. So let's go ahead and do some practice. Okay, here's an angle. It's 45 degrees. And they want us to list 4 angles which are coterminal to this angle. So 4 angles which end, terminal means end, right, at the same location as 45 degrees. So here's our 0, and so far the rotation has been 45. Let's get a pen going here. So you can see so far our angle started here, and we're going to go ahead and end at 45. Now coterminal means we need to add another 360, so let's go ahead and do one more rotation all the way around. What would be the measurement of that angle? Well, we go ahead and just take our 45 degrees, add 360 more. What do we get? Well, it looks like it's going to be 405 degrees. So we would say the angle 405 degrees would be coterminal to 45. It ends at the same place 45 degrees does. Now, let's go ahead and take one more rotation. So let's take that angle and let's go around once more. Ooh, it's looking like a caterpillar. Okay, so let's go ahead and take that 405 and let's just add another 360 degrees. Well, if we add another 360 degrees, that's going to get us to 765 degrees. Boom. We have 2 coterminal angles. Now, notice that I went counterclockwise in both of these examples. Counterclockwise is going to give you a positive angle. But what if I went the other way? So let's erase these 2 lines and say, instead of going forward, what if I went backwards? So still starting here, and let's go ahead. Oh, gotta get my pen going. So instead, let's go backwards, which is clockwise. And if you go clockwise, this is actually going to create a negative angle. So what we do is we start with our original 45 and just subtract 360 degrees. Well, what is that going to get us? Let's see, 45 minus 360 is negative 315 degrees. This would also be a coterminal angle to 45. You know, just for fun, let's go ahead and do one more because we need those 4 angles. We're not quite there yet, so let's do another rotation. So take that negative 315 and subtract another 360. We get negative 675. So here I've given you 4 angles which are coterminal to 45 degrees, or in other words, 4 angles which end at the same place 45 degrees does. So that was coterminal angles, and we have a formula for it as well that you may have picked up on, but just so you know, coterminal angles, I actually want to add a little something here. You're going to take your angle. And this angle is currently called theta. That's just a Greek letter there. So theta, whichever your angle is, plus or minus 360n. So I guess you really don't need the minus, but anyways, so theta plus 360n, where n can be any positive or negative integer. This will give you a coterminal angle. So in other words, we could have done, for this first one, it was 45 plus 360 times 1, which gives us 405. This one is actually 45 plus 360 times 2, which gave us this value of 765. And this one would be plus 360 times negative 1. And this next one would be 45 plus 360 times negative 2. So there's just a couple different ways you can approach this. Sometimes it's nice to look at the long way and then realize what that formula is there for us that helps us out there. So that is coterminal angles. Let's do one more example of a specific angle. So let's delete this mess. So here, give at least 2. So they're only looking for 2 coterminal angles for each angle listed below. The first one is 908 degrees. So most people will know, is that even ending in the first quadrant, second quadrant, third quadrant? I don't know. Where is it ending? So to get a visualization of this, it's better to find the coterminal angle which is within 0 to 360, because that gives us more of a visualization of where it lies when you think of that coordinate plane. So let's draw that coordinate plane real quick. So where does that angle end? I'm not sure. So let's go ahead and take 908. And I'm just going to go ahead and subtract 360 to start with and see where I get. Okay, so let's start with 908 minus 360. Where does that get me? Well, that gives me to 548. Well, I'm still not in the quadrants, right? It's because it's between 0 and 360. So let's go ahead and subtract another 360 degrees and see where I get. Okay, so 548 minus 360 gets me 188. Okay, so this gives me a much better visualization of where I'm ending. Okay, so 188, halfway is going to be 180, so it's about 8 degrees more. So that means that angle is going to end here. And in fact, if we look, you've had 2 extra rotations around. So if you really wanted to see what was happening with this angle, you could actually take 2 extra rotations, and that would be the angle 908 degrees. Okay, now we can do the same thing for negative 75 degrees and negative 800 degrees. Let's go ahead and draw our coordinate plane, because I like how that looks. You can check it out and visually demonstrate. Okay, so we had negative 75 degrees. Well, I don't know where that lies because it's negative, so how far are you going down? So let's go ahead and instead of subtracting 360, I'm going to go ahead and add 360 because that's the only way to get into that positive range. So negative 75 plus 360 gets me 285. Now let's see, 180 plus 90 is going to give me 270. So this angle is actually negative 75. I guess you could have figured that out if you really wanted to, right? So each one of these quadrants is 90 degrees, hence the right angle. So negative 75, you're going clockwise because it's negative, and you can kind of see it's going 75. Okay, so it's also the same angle as, if we drew it this way, 285. Now, it says we want 2 coterminal angles, so why don't we go ahead and let's do something different. Let's take negative 75. Let's make it more negative. Doesn't matter. We can make it more negative. Not a big deal. So negative 75 minus 360 gets me negative 435 degrees. So this would be another coterminal angle that's going to end right there. Okay, so we've done those 2 so far. I'm pretty sure, well, let's do one more just to make sure you guys got it. But let's do negative 800. So negative 800, definitely not in that region. So let's add 360. Always just adding or subtracting 360 degrees here. That gives us negative 440. Still not in that region, so let's add another 360. Negative 80. Oops, I wrote that wrong. So we want to add 360, which gives us negative 80. So here I already have two coterminal angles, but just for fun, let's try to get it into the positive region there. So let's add another 360. And you have 280. So you can see here, it's going to be a little bit past that 270 line. Okay, so negative 800, 1, 2, 3 rotations counterclockwise. 1, 2. Oh wow, I confused myself already. 1, 2, 3 rotations, and you get to that negative 800. Quite a bit, right? Okay, guys, so that was coterminal angles, so make sure you practice, but essentially it's just adding or subtracting 360 degrees. Good luck!